All right, hi everybody. We're gonna take some time here, go over the project for Introduction to Nuclear Energy. Before we do that, though, and go over the expectations for the project, I just want to just talk about a few highlights from the lesson and how that information will help you um, craft your assignment answers. So let's talk first about some of the objectives. So the lesson itself and how it relates to the project really it wants you to focus on being able to explain how the periodic table is arranged and the information that you can find on it because it's going to be helpful for you in terms of talking about different ions. Um, Being able to define isotope and radioisotope as it relates to nuclear energy. Can you describe the process of nuclear change? Can you explain what happens in reference to a nuclear chain reaction? Talk a little bit about some common sources of nuclear fuel, and then, of course, explain how uranium is processed to prepare it for use as nuclear fuel. So, um, for those of you who might not know a lot about nuclear power, the process in and of itself can be a little confusing. And for me, this is very much a first love, which was this was my first career choice. I was very fortunate enough to work for several years right out of college in a nuclear power plant up in northeastern Pennsylvania. So this is a topic that's really interesting to me. And while there is a lot of intricate details and complicated processes that we could talk about, we'll try and keep it simple. We'll try and keep it light and get you through the project. But your lesson really focuses on nuclear as a topic of clean energy, okay? Because it doesn't require the pollution that's a result of burning fossil fuels, and which was what we have talked about subsequent to this. So you may have heard some negative pictures being painted about nuclear power in terms of disasters such as Chernobyl or 3 Mile Island, or of most recent the Fukushima nuclear disaster in Japan as a result of the tidal wave, which I believe was back in 2011. So, you know, when you think about nuclear energy, many instances get a really bad rap, and because of the devastation that occurs, um, you know, it was it definitely is painted in a negative light. Um, but that's not always the case. Okay, so I want you as you go through this to kind of just make sure that you keep an open mind. You're certainly entitled to your opinion and your due diligence and your research. But with that, a couple of pieces that you want to make sure that you pay attention to. Obviously, being able to understand the elements in the periodic table, okay, and the arrangement that exists of those elements, so that you can accurately discuss defining isotopes and radioisotopes, okay, and as they relate, okay. Um, Also, making sure that you understand the process of nuclear power, okay, and how that occurs, okay. With that, really the key to this is understanding the process of nuclear fission, okay. Um, it's a change, okay, in which the nuclei of certain isotopes with large mass numbers are split into lighter nuclei, and as a result of that, when you split that, you release a tremendous amount of energy, okay. So making sure that you can understand that process will be important, and equally being able to identify the types of fuel that is used. So when we're talking about nuclear power, we're talking about specifically uranium atoms, either uranium 235 or uranium 238. Okay, are what are the fuels that we're going to really be focusing on, or you should be focused on for this. Okay, and especially how the process relates to the splitting of both 235 and 238 atoms. Okay, so with that, let's take a jaunt over here to the actual assignment. Okay, um, the directions are essentially fairly simple. Okay, it gives you 5 questions. Okay, that it wants you to discuss, and there's you're going to have a whole bunch of ways to do this. Okay, um, but what's going to be important in all of this is how well you support your answers for me. Okay, and that's where I want to make sure that we're clear on the expectations for this. Okay, so we'll go through this one by one. I would suggest doing this on a Word document, saving it and uploading it, because it's going to require a little bit more space and a little bit more time. Okay, so the first question: the element carbon has 3 natural isotopes: carbon 12, carbon 13, and carbon 14. Okay, what you're going to do is you're going to use the periodic table to find the number of protons in a carbon atom. You're going to then make a drawing to show the nuclei of the 3 carbon isotopes. And your drawing should convey the number of protons and neutrons in each of those 3 different nuclei. So if you're real fancy and you want to, you know, create some type of diagram with a Word document, you can do that. You can hand draw it, and you can upload it. You can take a picture of it and upload it. It's your choice on this one. Okay. Um, some other people have taken pictures. They've saved those pictures and they've then uploaded those pictures to their computer and then just pasted them right into the Word document. All right. So the next question: carbon 12 and carbon 13 are stable, is where carbon 14 is unstable. Which isotope of carbon is most likely to undergo natural radioactive decay, and which one would be called a radioisotope? So for this one, I would suggest that you go back into your lesson. Okay, if you're having trouble with this question, go back into the lesson where it talks about isotopes and radioisotopes. Okay, it's on the periodic table section. Okay, so it's in the first page or two of the lesson. You can easily identify your answer and put it in there. Number 3, explain the 3 processes of nuclear change and what is produced as a result of that change. Again, I'm looking for support, but you can find all of those answers again right in the lesson. Okay, on the page where it begins to talk about nuclear power, there's a heading that says nuclear changes. You can summarize those 4 points and get them in there. Okay. Number 4, why is uranium 235 the most common nuclear fuel instead of the more abundant U-238? Again, the lesson gives you an outline of the types of nuclear fuel, both 235 and 238. So what I'm looking for is to give me a topic sentence, why one is more common, why 235 is more common, and then support it with the evidence that is in the lesson. If you choose to go outside of the lesson, and to do research at the Nuclear Energy Institute, please make sure you cite that and support that in there. Okay, and then finally create a flow chart to show how uranium is processed for use in a nuclear reactor. Okay, so again, you can do this either by drawing it, or you can actually give me a word flow chart with arrows, which is equally as good. But just with that, again, where are you getting your sources is all I care about. If you're going to use the Nuclear Energy Institute, that's fine. If you're going to use, INPO, the Institute of Nuclear Power Operators, or the Nuclear Regulatory Commission, I'm fine with those sites as well, as long as you cite them properly and support um, your your answers with those reputable sites. I'm more than fine with that. So what I'm looking for with this is clear, concise answers that fully answer the question. Um, I'm looking for sources, and I'm looking for some paragraph format for these. Okay. I'm also looking for that those of your drawings that you're going to do are going to be constructed well and cleanly so that I can interpret them. So if they're done computer aided or by hand, I can interpret them. Okay. So with that, that's pretty much everything. If you have any trouble with the project, I'll be more than happy to assist you in the virtual office or through email. We'll be back here next week doing a new project. And if you have any further questions, please seek me out throughout the week. And have a great week, everyone.